All right, here we go. Today, I'm stealing directly from your book. I don't, but I'm stealing directly from it because it's good enough today. We're doing it live.
It's good enough for them to steal from us.
On occasion. Let's talk about shopping. All right, words are hard, math is easy. Here we go. Story problem. It says, at a sale, Sarah bought 4 t-shirts and 3 pairs of jeans for $181. Ooh, Jenna is not buying on a sale. Jenna bought 1 t-shirt and 2 pairs of jeans for $94. The t-shirts were all the same price and the jeans were all the same price. So the following system of equations represent the situation. Determine the best method to solve this equation. All right, so we need to set up an equation to represent Sarah's purchase and Jenna's purchase. So here's how we're going to do it. How much money did Sarah spend in total? Awesome. So that's the total amount. And that's comprised of the amount of things she bought and their price, right? So if I knew that I bought 2 jeans at $15 each, how much did I spend total? 30 bucks, right? So the number that you bought times the amount it costs gets you the total amount you spent, right? So how many t-shirts did she buy? 4 t-shirts. How much did the t-shirts cost? I don't know, but it's going to be 4 times whatever the cost of the t-shirt was, right? Now that's not all she bought. What else did she buy? 3 pairs of jeans. So 3 pairs of jeans. Right? That expression, or that equation, I should say, represents how much money she got, or how much money she spent, right? We don't know the price of the t-shirts and the jeans, but we know that if we did that and multiplied them by 4 and 3 respectively, we'd get the total amount she spent, right? More or less, we're ignoring sales tax and all that garbage. Now, same thing for Jenna. So how would I set up Jenna's equation? Somebody read me the entire equation for Jenna. Think of it in your head and then tell me what it's going to be. Raise your hand so we can do this. Yeah, what's up? 94 is the total amount she spent. 1 times T, because she bought 1 t-shirt. And then 2 pairs of jeans. Now, I'm doing parentheses just for the heck of it. You don't obviously have to do that. You could just write J, or 2J. That gets the job done. Now, this is a system of equations. Why is it a system? Because the price of the t-shirts and the price of the jeans were all the same. So that T is the same as that T, and that J is the same as that J. So they're related, which means they are in a system. What form are these equations in, these linear equations? What form? Standard form, right? Is our T matched up with our T? And our J with our J? On the same side of the equal sign? What's going to be the easiest way to solve this, you think? Elimination. So we need to get coefficients to match up. Do you want to make the 4 and the 1 match up or the 3 and the 2 match up? 4 and the 1. All right. So what do I multiply either the top and or the bottom by to get them to match? Yeah, we can just do the bottom by 4, right? So the top I'm going to keep the same. And again, don't need the parentheses. And the bottom, I'm going to multiply the 1 by what to get it to be a 4? I'm going to multiply by 4, which means I also have to multiply the 2 by 4. There's a joke there. And I get 8. Now, 94 also has to be multiplied by 4, so let's do that in our head. Let's round the 94 up to 100. 100 times 4 is what? 400. Now, we overshot 6 each time, right? So we did 6 too many 4 times. Minus 24, right? What's 400 minus 20? 380 minus 4 more. So 94 times 4 is 376. Another way you could have done it, round down. 4 times 90, 360. 4 times 4 is 16, so add 16. 376. very adorable. In 7th hour algebra class in high school with a juice box. It's okay, I understand. I don't want you to pass out either.
I'm anemic.
Guys, anemia is no joke.
That's what I'm trying to say.
As a vegan, I'm anemic naturally because like iron is typically like injected into meat, and since I don't eat meat, right, I don't get that injected iron that you guys all get, right?
You're straight vegan?
Well, I mean, I guess I'm vegan like probably 6 out of the 7 days a week on accident.
Do you like
I'm definitely vegetarian, but I oftentimes don't eat eggs. Like, how often do you guys eat eggs? Not every day, right? And I don't drink milk every day or eat cheese. So that happens.
Do you eat any meat?
No. So I'm definitely vegetarian, but I'm like accidentally vegan a lot of the time.
Marta eats chicken, that's about it.
Yeah, I understand that.
He said because they have tiny legs.
All right, interesting. So now that we have these, we can make them go away. How are we going to make them go away? Addition or subtraction? All right, so we're going to subtract everything. 181 minus 376. Woo! How are we going to do that? What if it was 81 minus 76? Could you do that? It'd be 5, right? 100 minus 300, negative 200, right? Dang, right? Does that work? What's 100 minus 300? Why do you disagree? You do, right? That's a good point. But we're not done yet, so maybe it'll go away, right? Is 181 minus 376 negative 205? Is it? How do you know?
Because 0 plus 8. No,
So what she's doing is she's saying what we should have done was this, right? And if we undid it, we should be able to add that over and get 376, right? And do we? We do not, right? We don't. That won't equal 376. So what's a better way of thinking of it?
Flip it.
81 minus 76 is 5, right? 100 minus 300 is negative 200. 81 minus 76 is 5. 100 minus 300 is negative 200. And you said the answer was negative 195? It's because that 5 is positive, right? If it was negative, then we get negative 205, like I said. But it's not. It's a positive 5 here and a negative 200 there. When we put them together, we get negative 195. I'll say it again. 81 minus 76 is positive 5. 100 minus 300 is negative 200. When we put them together, we get negative 195. Not negative 205, right? Jordan? 81 minus 76, 5, right? 100 minus 300, negative 200. When we put them together at the end, last time I put them together and I said 205, right? But the mistake is that one's negative. So it's negative 195. So we have negative 195 equals, what's 4t minus 4t? 0t. 0t is 0, right? So we don't have to write it. 3 minus 8 is negative 5j. Now you're right to say that we can't have negative dollars, right? But what's going to happen when we divide this? It's going to become positive again, right? So j is what we're solving for. How many times does 5 go into 195? How many times does it go into 100? 20. How many times does it go into 200? 40. One less than that. 39. J is 39. Does that mean she bought 39 jeans? What does it mean? 39 bucks a pop. Which ain't too bad, ladies, right? 39 bucks for a pair of jeans, brand new. Yeah. I like being a guy. 30 bucks max. So now that we know how much the jeans cost, how can we figure out what the t-shirts cost? Jace. Which one do you want to plug it into? The top or the bottom? The top? Why would you rather plug it in the bottom, Jace? Instead of timesing by 3, right? So when I plug it into the top, I've got 94 equals t plus 2 times whatever j is. Whenever I plug something in, I wrap it in parentheses. It's 39. How do I do 39 times 2 in my head quickly? 2 times 40 minus 2, right? 38. Sorry, not 38. 78. 2 times 40 is 80, but we overshot it by 1 twice, right? Now I'm going to subtract 78. The way I'm going to do that is I'm going to count up 6 more to get to 4, and 1 more to get to 90. $16 t-shirt. Yes. Oh. It's going to smack it out of the air. Like that bird that went in front of the pitcher that one time. Fastball. Just exploded. So, what have we learned? We've learned that what would normally be an impossible problem, or with infinitely many solutions, I should say, right? I spent $181. I bought 4 t-shirts and 3 jeans. How much did each cost? I don't know, man. Right? Lots of possible solutions. I could have had, 25, 20. Could have had 45 pairs of 45 t-shirts you could have bought. Not 45. But you see what I'm saying? There's lots of possible numbers that you could plug in there. I'm way too tired by 7th hour to do this. Lots of numbers that I can plug in and make work. And that makes sense because this right here represents a line. All the possible combinations. So this guy's a line, right? And so is this guy. And where they intersect is going to be the one thing that they agree upon, which is going to get us the one solution that works. Does that make sense? Normally we have too many variables to solve, right? 2 things going on, only 1 equation. But if we have 2 variables and 2 equations, then it is solvable. We can solve it using elimination. How do you feel? Was the hard part multiplying in our heads and adding and subtracting in our heads? Was that the hard part? Okay, that's fine if that's the hard part. Calculation is hard. How do we feel about the concept? 2 equations in standard form. Do elimination, get them to match up, right? Subtract them, make them go away. Get one of the variables, plug it back in, get the other. How do we feel about that concept? What we're doing here. Troy? Jordan? Okay, so the question is, where does it hurt? Do you see why I did what I did here? And how I did it? Okay, so what I did was I wanted these 2 to match up, so when I subtract them, they go away. So what I did is I multiplied the bottom by 4 to each of these. And now when I subtract them, I get some number here, minus 195, okay? Trust me on that. 4 minus 4 is 0, so 0 t's. It goes away. And I'm left with just 3 minus 8, which is 5, negative 5. And that gets me j. See how it eliminated one of my variables? And it gave me 1 equation with 1 variable? Then I can solve, right? Then afterwards, I plugged it back into a different one and got t. Better? Okay. Again, problem this small, she just didn't see it. So if you ask, now we're good. Yeah. All right. The most important thing, though, is the setup. Do we see how we have 2 different things going on here, and they're going to total up to something? So the way you set up a problem like this is you need to think about what's going on, right? She spent a total amount of money. What's that made up of? Well, it's made up of t-shirts and jeans. How many did she buy of each? That's your coefficients. Here we go. This one down here. Jared has volunteered 50 hours and plans to continue volunteering 3 hours each week. 3 hours each week. Clementine has just started volunteering, so different idea, different person, right? She's just started volunteering, so how many hours has she gotten so far under her belt? 0, right? So that's important. She's going to volunteer 5 hours each week. So who's doing more per week? Clementine. So while she's starting out with less hours, she's adding on more every week. So at some point she will catch up, right? The question is when? How do we write a system of equations to represent this? You doing all right, Shion? How may I help? There is one back there for iPhones. And there's a adapter if you have the wire, but not the wall adapter. Jared has volunteered 50 hours, and he plans on adding 3 hours more each week. Now, this is not going to be an equal sign. We're not going to have an equation here because it doesn't tell you how many hours he has total, right? So it's just going to be an expression, no equal sign. How do we represent Jared's work as an expression? 50 plus 3 variable. Let's call W for weeks. That's how much Jared's working, right? He's starting with 50, then he's adding on 3 hours every week. Make sense? Okay. This is Jared. Clementine. It's a great name if you're in a zombie apocalypse. Shout out to my Walking Dead Telltale series, right? Yeah, that's how I know it. I think I played the Michonne arc line, but like, or no, the season 2, but I didn't get very far. I got like halfway. Thank you. All right, so Clementine, how are you going to represent her volunteering time? Just 5W, right? She has nothing starting out. So just 5W. And the question is, when will they have worked the same amount? So how do I figure that out, you think? What are we asking? Yeah, when will they be equal, right? That's the total amount of work for him, total amount of work for her. When will they be equal is what we're asking. That's not hard to do. That's not even a linear system, is it? It's a single equation with single variable. What does that mean? There's the answer. What does it mean?
I've done that here before.
What? Yeah, so after she works 25 weeks, they'll be equal. And that makes sense, because 25 times 5, that's going to get 125. 25 times 3 is 75, plus 50 is 125. So that's when they'll be equal, right? And any time after that, she'll have worked more, right? She's coming after you, Jared. What? Subtract 3 what? 3W? I moved over to the 3W by subtraction. Better? Okay. That's not even a linear system. So let's get back to a linear system. Nice shot. 26. In 2003, distant past, the United States produced about 2 million more motor vehicles than Japan. I know, right? Economy was different back then. Together, the two countries produced about 22 million. How many vehicles were produced in each country? How are we going to set this up? That's what I want to know. Someone other than Parker. Parker's got it.
Finally, I said don't do it.
right. How do you solve a problem like Maria? How's the setup? No. We don't. What are our variables to start out with? What don't we know? That'll be our variables. We don't know how much Japan made, right? So let's call that J. So J is going to equal number of Japan vehicles, right? We'll call them cars. Right? So that's something we don't know. What else do we not know? We don't know how much the U.S. made, right? Now, what's the relationship? Let's talk about the relationship that we know. Together they did 22 million. So if I do U, what? Yep, 22 million. We'll do 22M. Okay. Let's just do 22. I don't want you to think that's a variable. Okay. What else do we know about the relationship? The United States produced about 2 million more than Japan. How do we write that? We don't need an inequality. We don't need an inequality. We can write it with an equal statement. U plus J times 2? J is doubling, right? If you double it, 2J would be doubling it. So that's not what they're talking about, right? You're onto something. It's tricky. I want to think about it for a while. I want you guys to think about it. Why are we doubling the number of U.S. cars? You see what I'm saying? Remember, U stands for the number of U.S. cars. J stands for the number of Japanese cars. Nope. Yeah, it's going to be U something, right? Because it's United States produced 2 million more than Japan. So there's some relationship between U and J. U equals double the amount of J? Boom, she got it. Now, why is it J plus 2 and not U plus 2? Right. A lot of people are going to want to write U plus 2 because the United States, 2 million more, right? And they think U plus 2. But in reality, the amount the United States produced is the amount Japan did, but with 2 more, right? If you add 2 to the amount Japan produced, that's the United States. So here's our system of equations. Okay, cool. So I'm going to write that down bigger up here. Here's our system. U plus J, good luck, equals 22. U equals J plus 2. They're a linear system because U and J are referring to the same thing, right? How do you want to solve this? What method? Tell me what method. Substitution, elimination, graphing. Substitution. Nevaeh's method. Nevaeh, how are we going to do substitution? What's the easiest way to do it, you think? Good. So walk us there. How do we get that? Because I think a lot of people hear that and they're like, what? Shut up and listen to Nevaeh. Yeah, exactly. So instead of writing U plus J equals 22, we're going to write whatever U is plus J equals 22. Before we had two equations with two variables. But after we do a substitution, instead of having two variables in one equation, we're only going to have one variable, j. And that's going to give us something that we can work with, right? So now we have j plus 2 plus j. Well, we don't need parentheses, all addition, right? So it's 2j plus 2 equals 22. Subtract 2, divide by 2, right? Or we can divide by 2 first. What do you want to do? Let's divide by 2 first, just for the fun of it. What do we get? J plus 1 equals 11. And then subtract 1, we get 10. Right? Could you have subtracted 2 and then divided by 2? Sure, right? But again, PEMDAS is a lie. You can do whatever you want as long as you're clever. When you divide, everything gets divided because division is divorce. So J is 10. That means 10 million cars produced by Japan, which means how many cars were produced by the United States? 12, because you remember that you just add 2 to it, right? That's what this guy means. So you could go back in and plug it in, or you could just remember whatever Japan does, we add 2 to it, and that's US. How do you feel? Better? Are we feeling better about the setup here? Right? Think about the total, right? 22 million between the two. I think that was the one everybody got and saw real quickly. The U plus J equals 22. That was good. The tough one was thinking about how they relate. How they relate. Try another one. Did someone just say ski? Gotcha. Not like ski, 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 ski. Like that? Like, aw, ski, 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 ski. No? Okay.
I know what it's all.
I bet you do. I had an administrator. Oh, God. My administrator last year. Minnesota Nice. Hey, how you doing? Right? Don't you know? So wholesome. And she's sitting outside. This person is awful. She's a horrible human being. She was sitting outside the homecoming dance, right? And I'm passing her because I'm there super late and I'm going home, right? So I'm walking out through the hallway. And she's sitting there with her Minnesota Nice, everything's got to be so perfect and great. And inside the gym where they're doing the homecoming dance, all you hear is, "To the windows!" Right? And there she is, and I just look at her and I go, oh my God, right? Meanwhile, I'm too risque, right? The freaking homecoming dance, we're playing, Okay, anyway. 15.
That's a good song. That's a funny song.
Song of the day. Tomorrow. I will be fired immediately. And I'll be like, what do you mean? They played at the homecoming dance last year. Obviously fine. All right. Race. In a race, Pablo is 3 miles behind Mark. Pablo increases his speed to 5 miles per hour, while Mark continues to run at 4 miles per hour. At this rate, how many miles will Pablo have to run to catch up to Mark? How long will it take? All right, let's set it up. Who wrote this book? Phrasing. All right. Pablo is 3 miles behind Mark. How do we write that? Pablo increases his speed to 5 miles per hour, while Mark continues to run at 4 miles per hour, right? So what are our variables? What are the things we don't know? This one's tough. We don't know how fast they're going now, but we do know how fast they will be going, right? So 5 miles per hour, we can write that down, right? 5 miles per hour, 5 times h. Now, when we do miles per hour, 5 miles per 1 hour is what that means, right? What does h stand for? An hour. So check it out. What we really have here, instead of 5h, is we have this. 5 miles per 1 hour times h. Now, check it out. H stands for hours, and this stands for hours. So we're timesing by hours and dividing by hours. Hours cancel, and what we're left is with miles. If you take miles per hour and times it by the number of hours you're driving, you get the location you're at, right? How many miles? If I'm driving at 5 miles per hour, and I'm doing it for 5 hours, I've done 25 miles, right? And the reason it changes from miles per hour is because hours and hours cancel. And you get miles. So this is what we have going on here. So he's increasing his speed to this. Mark continues to run at 4 miles per hour. So whatever Mark was doing, he was doing 4 miles per hour before. Okay. We want to know where they are. Pablo's 3 miles behind Mark. So how about P and M stands for the location of Marco and what do we got here? Pablo. Mark and Pablo. Marco Polo. Their location. Marco. All right. So it says Pablo is 3 miles behind Mark. So here's Mark's location. How does that relate to Pablo's location? So Mark's location is whatever Pablo is minus 3. Other way around, right? Mark minus 3 is going to give you Pablo's location. Right? Because Mark is 3 miles ahead. So if you take his stuff and subtract 3, you get Pablo's. Do you see that's counterintuitive? You really got to think about what you're doing here, right? Otherwise, you're going to say what he said and say M equals P minus 3. Right? Cool. Well, great. Awesome.
Fantastic,
Right.
Olivia.
All right.
So smart. Proud of you. You should go D1.
We got a lot of variables here. We got M's, P's, and H's.
What is happening in my life today? Me too.
So check it out. What I said before. Miles divided by hours times hours. Don't the hours cancel and we get miles? Isn't miles location? Well, that's Pablo's location. That's P. Isn't this Marco's or Mark's location? Marco Polo? Do you see how these are locations? Because hours and hours cancel and we get miles. So these are the same. So instead of M, can I take this and plug that in? And instead of P, can I take this and plug that in? Okay, this one's weird. So M is 4 miles per hour times hour. So I'm just going to write 4H, right? Because 4 divided by 1 is 4. Hours and hours cancel. We just get miles. It's going to be 4 times H. Minus 3 equals 5 times H. And then I subtract 4H from this side and I get 1H. So H is negative 3. Now what does that mean? Yeah, right? H is the number of hours. So in order for Marco to catch up to, or Mark to catch up to or Pablo to catch up to Mark, or whatever it is, right? They have to run negative 3 hours? How does this make sense?
He has to walk backwards.
Yeah, makes sense.
Why take break?
He's 3 miles behind Mark. 3 hours ago they were at the same spot. That's a good way of putting it, yep.
Wait, you get... This chair is very smooth.
I'm sorry. I'm sorry I made you move there. I know that was the joke.
Were you gonna divide by a negative?
To get rid of the negative? That'd make things better. But why didn't we? Did we goof it up?
Very possible.
Pablo is 3 miles behind Mark. So he's, whatever Mark's location is, minus 3. That checks out, right? While Mark continues to run at 4 miles per hour, so he stays the same pace, and Marco increases to 5 miles per hour. How many miles will Pablo have to run to catch up to Mark? How long will this take? Well, we figured out the time it will take. It'll be negative 3 hours.
If you put...
Then why do we get negative 3 and not negative 4 or negative 5? You know what I mean? What's the significance?
Because you tricked us somewhere.
Let's think about it. Here's the race.
Realistically, you tricked us.
Here's Mark. There's Pablo. Whoops. P, not B. If Mark goes ahead at 4 miles per hour, then he's going to be here now. 1, 2, 3, 4. That's after 1 hour, and now he's here. If Pablo goes ahead at 5 miles per hour, 1, 2, 3, 4, 5, he'll be here. So after 1 hour, he still hasn't caught up. What about after 2 hours? Will he have passed him? Let's see. Mark's going to go ahead at 4 again. 1, 2, 3, 4. And Mark's going to end up here. Nope, he'll catch up. So Mark's going to go ahead here. 4 more miles, right, for Mark. And Pablo's going to go ahead 5. 1, 2, 3, 4, 5. So now Pablo's here. So that's after 2 hours, right? After 3 hours, Mark's going to be here, 5 ahead. 1, 2, 3, 4, 5. So Mark is here. And Pablo, 1, 2, 3, 4, 5. One behind. Good catch. 1, 2, 3, 4. They finally catch up. 3 hours. Let him sleep. So they do catch up at 3 hours. Let him sleep. So they do catch up at 3 hours. So why do we get a negative answer?
Wait, can we go back a minute?
Mm-hmm.
So, how you get 4H
Yeah, he's
plus
getting
3
ready for,
equals 5H, and you subtract 4H. You get negative 1H. And then you gotta divide by negative 1, and make the negative 3.
4H minus 5H minus 4H is 1H.
Oh,
It's okay. Isn't it true that if you take Mark's distance and subtract 3, you get Pablo? Well, here's Mark. Here's Pablo, right? 3 apart. That checks out, so this is true. This is true, because Mark was running at 4. Pablo was running at 5. With 3 apart. Why do we get negative 3 and not positive 3?
I just. Hey, I'm doing the very first turn.
We're subtracting.
Meaning what? Okay.
So this is P, and this is M, and that's minus 3. Isn't M minus 3 equal P? Isn't that what we established earlier?
The other way too.
Or did we write it the wrong way? Is it M minus 3 equals P? If you take Marco's location and subtract 3, you get Pablo's. Or sorry, Mark's location and subtract 3, you get Pablo's? Right, because Mark's 3 ahead, right? So that's the right equation. Why, when we plug it in, do we get negative 3 for H? I know, right?
Can I shake your hand? I need to do that.
Well, moving this way is increasing by 3 hours, right? If we went to the left 3 of those times, would they match up? They would. You're not wrong, but I don't think you know what it means yet. So I can't say yes. When I plug in negative 3 for H, I get negative 12 miles minus 3 equals negative 15 miles. Negative 3 for H gets us negative 4 times, 4 times negative 3, which is negative 12. That's going to be miles. Minus 3 more is 15 miles, negative 15 miles, which is what we get over here. If I made this a plus and change that, That means I did this. That, if I rearrange this equation, P plus 3 equals M. We do? Who?
Tucker Fish.
All right, Tucker can wait. Tucker can wait. And I rearrange it like this. P plus 3 equals M. P plus 3 equals M. M minus 3 equals P. It's the same way of writing it, just a different way of thinking about it. 1 is assuming we're starting here on the left and adding 3 to get to Marco, because we're trying to move in that direction. The other was saying M minus 3 equals P. And it would, but it's moving to the left that way. So it's all about the direction. So if you go back 3 hours or you go forward 3 hours, they would match up. I think I'm losing everybody here. I think everybody's kind of dozing off. Our original equation that we said was M minus 3 equals P. If you take Mark's position, subtract 3, you get Pablo's position. I rearranged that by calling this a positive 3 and making that, rearranging it and making it look like this. I multiplied everything by a negative 1, which is valid, right? I can do that. And when I do this, I get M equals P plus 3. I can rearrange, put the P over here, make it positive, put that over there. So both of these equations are saying the exact same thing. One is saying I start at Pablo and I add 3 and I get to Mark. The other is saying start at Mark, subtract 3 and you get to Pablo. The difference isn't algebraic. The difference is how we think about it. If I'm adding 3, I'm moving to the right. Time is moving forward. If I'm subtracting 3, time is moving backwards. So when we had it this way, that's why we got a negative 3 here. Because time was moving backwards. We were saying subtract 3. This one time moves forward. That's it. I think I've lost you. I think you have about 25% understanding, which is fine. But that's what happened there. Wild, huh? There's no reason, mathematically speaking, why time shouldn't be able to move forward or backwards. None. So the question is, who's right? Our perception of time or math's perception of time? Could be neither. That's kind of fun. $20. Write this down. This is your homework. The whole thing. Or take a picture. Take a picture. Yep, this is your one thing I want you to work on. Come up with the system of equations and then solve it. $20.
You got stanky feet?
That's okay.
You want a smaller?
Yes. Yes.
We'll talk about this tomorrow. I'll let him in. Nothing. That's just giving you a heads up of what's coming down the line. If you want to start writing your math autobiography, that's great. Or start collecting your journal entries to talk about how how things have changed this semester. You can start doing that. But I'll get you a rubric after Thanksgiving.
So all this we have to have done. When is this due?
Right before the final.